Okay, back to our example. Our class width we found was 16. So step 3 is where we specify what the classes are. That's the first column of the frequency distribution table. Okay, so to find the very first class, which is the first row, we're going to put the smallest data value first, and that is considered the lower limit of the first class. Our smallest data value in this example is 10, so 10 is the lower limit of the first class. Okay, then what we do is we add the class width to that 10, and then subtract 1, and that's the upper limit of the first class. So since the smallest data value is 10 and the class width was 16, we take the smallest data value, lower limit, plus 16 minus 1, and that gives us a 25. Therefore, our first class is 10 to 25. And this is what goes in our first row of the first column. Now to get the next row, well, we go to the next number after 25, and that's 26. So the 26 becomes the lower limit of the next row. And then we follow the same calculation. We would take the lower limit, which is 26, plus 16, the class width, minus 1, and that will give us 41. And so our next row is 26 to 41. Then we increase 41 by one number, so we get to 42. We add 16, then minus 1, and that gives us 57. Now we continue doing this for all 7 classes. There is a shortcut. Once you get the very first row, you can quickly fill up this entire column of classes by simply noting that if you take 10 and you add the class width, which is 16, you get 26. If you take 26 and you add the class width, which is 16, you get 42. Plus 16 is 58. Plus 16 is 74. Plus 16 is 90. Plus 16 is 106. Then if you take the 25, plus 16 is 41, plus 16, 57, plus 16, 73, and so forth. And you do this until you have all 7 classes created. So this means that our classes are going to contain, our data is going to be placed into these classes. So if we have a data value that happens to be a 12, for example, a 12 would fall in this class. If we had a data value that was 45, it would fall in this class. Okay, so the classes are groupings. Now it doesn't necessarily mean that we have a data value of, let's say, it doesn't necessarily mean that we have a 58 or a 73. It means that this is the group where our data values will be placed. Okay, so each class should have exactly 16 values. When we constructed the class width to be 16, we are identifying the fact that every class has exactly 16 values. So for example, the first class, which goes from 10 to 25, if you list all the numbers from 10 to 25, 10, 11, 12, 13, all the way to 25, and you count how many values this is, it should have a size of 16, and it does. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And with a frequency distribution table, every single class must have the same exact size. Okay, everything's got to be even like that. So if you count how many values are between 26 and 41, including 26 and 41, there will also be 16. Okay, the class frequencies make up the second column. And what we're going to do is look at our calculator and count how many data values fall between the upper and lower limits of each class. So with your calculator list open, I can open that too. Our first class is 10 to 25. So we open up our list, press Stat, Enter. Open up our list and notice that between 10 and 25 there's only one data value. So the frequency for the class 10 to 25 is simply 1. Okay, so if we look at the number of data values between 26 and 41 on our calculator, you'll see the frequency for the second class is 6. And here's what you do there. 26 and 41. So you count. 30 is 1, 32 is 2, 35 is 3, 37 is 4, 38 is 5, 39 is 6. And then 42 is in the next class, so we wouldn't count that. We have exactly 6 data values in our raw data that fall between 26 and 41. So the frequency for the second class is 6. And we continue this for all 7 classes, going down the calculator's list and counting how many data values fall between the class limits. And then we populate the second column of the frequency distribution table. So this is what you should have. 1 data value in the first class, 6 in the second, 14 in the third, 13, 14, 1, and 1. So if you want, take a minute and pause the video and verify that you can do that on your calculator by going through the list. Okay, if you add up all the frequencies, you should get 50, which is the total number of data values. Okay, we started with 50 data values in our distribution, and if we add all these up, we have 50 data values. So it means that every data value is placed somewhere in one of the 7 classes. Okay, class marks become the third column of the frequency distribution table. We find the class mark by taking the upper class limit plus the lower class limit and dividing by 2. Okay, so if we look at our first class, which is 10 to 25, the lower class limit is 10, the upper class limit is 25. So to find the class mark, we will add these two, 10 plus 25, and then divide by 2. And that gives us 35 divided by 2, or 17.5. And for the second class, we would do 26 plus 41 divided by 2. That's 67 divided by 2, or 33.5. And that would be the class mark for the second class. Now, there is a shortcut. Once you find the very first class mark, if you add 16, our class width, that class width seems to come up a lot. We add the 16, the class width will get 33.5. We add 16 again, 49.5. Add 16, add 16, add 16, add 16, and you can populate the entire class mark column. Okay? You just have to make sure that very first class mark is correct. If it's not correct, then everything else will be incorrect if you keep adding 16. So you just want to make sure that that first one is perfect, and then when you add 16, everything else will fall in line. Okay, class boundaries become the fourth column of the frequency distribution table. And all we do with class boundaries is we look at the class for the row, and then we subtract 0.5 from each lower class limit, and we add 0.5 to each upper class limit. So, for example, for the very first row, the first class, we take the 10 and we subtract 0.5, and we take 25 and we add 0.5. So our class boundary becomes 19.5 to 25, 9.5 to 25.5. And then we do the same thing for the second row, the second class. We take 26 and we minus 0.5, that gives us 25.5. We take 41 and we add 0.5, and that gives us 41.5. And we do the same for all the classes. Now, what you notice happening with class boundaries is that it reduces any gaps in data. It basically turns discrete values into continuous values. Notice how there's a jump between 25 and 26. So a value, for example, of 25.5 doesn't have any place to go. There's a gap between 25 and 26. There's a gap between 41 and 42. In class boundaries, notice how it's perfectly continuous. 9.5 to 25.5, and then there's no gap. 25.5 to 41.5, 41.5 to 57.5, and there's no gap in these values. Okay, relative percentage is the percentage of data values within each class. So they become the fifth and final column of the frequency distribution table. You first add up the class frequency column to find the total number of data values. Now we already know that we started with 50, so by adding up this column we'll get 50. Then for each class, we divide the class frequency by the total number of data values and then multiply by 100. We round this percent to 2 decimal places, which is the nearest hundredth. So for the very first class, we take 1, the frequency, we divide it by 50 and multiply it by 100, and that gives us 2%. Now if we had any decimal places, we would round it to the nearest hundredth. So for example, if it were 2.25, we would keep it as 2.25%. 6 divided by 50 times 100 is 12%. 14 divided by 50 multiplied by 100 is 28%. 13 divided by 50 multiplied by 100 is 26%. So let me demonstrate what you're doing on the calculator here. $13 is the frequency for that class, 50 data value total, and then multiply that by 100 to turn it into a percent, so 26%. Now if by chance you had 51 data values, notice that it's not a nice terminating decimal. So when you turn it into a percent by multiplying by 100, it's also not terminating. So I'm going to ask you, if you ever have a situation like this and you have to round to the nearest hundredth, it would become 25.49%. Okay, nearest hundredth means 2 decimal places after the decimal point, so that would be 0.49. Okay, so if you need, copy these down: 2, 12, 28, 26, 28, 2, and 2. And that completes the frequency distribution table. So now we can answer some questions on this table. If we look at this table, what percent of the students study between 26 and 73 hours per week inclusive? Well, the word inclusive there means that we're including the number 26 and 73 in our calculations. What percent of students study between 26 and 73, including 26 and 73 hours per week? So we have to look at their classes, and we see that 26 is the lower limit of the second class, and 73 is the upper limit of the fourth class. And if we didn't see 73 as the upper limit of some class, or if we didn't see 26 as the lower limit of some class, then we probably did our work incorrectly, because we wouldn't be able to answer this question based on the frequency distribution table. Okay, if we are asked to look at a frequency distribution table and answer this question, then 26 must be a lower limit and 73 must be an upper limit. So 26, the lower limit, has 12% in that class. 73 is the upper limit. There's 26% in that class. So everything between 26 and 73 includes the percentages 12, 28, and 26, which need to be summed together. So adding those three percentages together gives us the total number of students that study between 26 and 73 hours per week. So adding that up, we'll get 66. Another question we could ask is, what percent of students study more than 90 hours per week? So 90 is the lower limit of the sixth class. Anything more than 90 would be values greater than 90. So we're looking at 2% plus 2%, which is 4%. So the answer here would be 4%. Now, both of these questions asked what percent of students. That's why we're using the column relative percentage, because it's asking for a percent of students. If it said what number of students, we would be using the frequency column. So what number of students study between 26 and 73 hours per week? We would add 6 plus 14 plus 13. So this would give us 33. 6 plus 14 plus 13. If we were asked what number of students study 90 or more, we take the 1 and 1 and we get 2. 2 students study 90 or more hours per week.